Okay, we're checking, 5-1 practice worksheet, page 8, it says at the bottom. If there's any of these you don't understand, let me know, and I'll stop and I'll work them. If you miss any part of it, put a slash through the number, and then I'll go back and decide how many points you get of that, okay? And like I said, 1 through 7 has 2 answers, and you must have both those answers to get full credit. If you don't have both of those complete answers, then you need to put a slash through it, and I'll go back and see how much you get. Okay, so number 1, this, like I said, is 5-1 practice worksheet. If you have questions, let me know. I'll pause and I'll work it. Also, y'all need to help me since I'm recording. If I start writing out of bounds, let me know because they won't be able to watch it. And y'all can't see it either. So interrupt me and let me know. Okay, so number 1, the perimeter is, now you don't have to write P equals, but you need to have 112 centimeters. Must have the number, must have centimeters. If not, put a slash through it. You must also, and I'll go back and check this myself, but you have to show your work to get credit. Okay? The area is 336 square centimeters, or you could write it as square centimeters. Okay? That's number 1. Anybody need to see how to work those? Okay. All right. Now we've got number 2. Number 2, the answer is, the perimeter is 180 yards. And the area is 1,350 square yards. Okay. Everybody good still? Number 3, the perimeter is 230 miles. Okay. And the area is 3,294 square miles. Now, on all these where I wrote like yard square, you could write square yards. That's fine. Okay? So, all right. Number 4. The 2 answers are, the perimeter is 192 millimeters, and the area is 2,304 millimeters squared. Okay. So do y'all need to see any of those worked out? Or are you good? Okay. Number 5. The perimeter is 113.57 feet. And the area is 498.84 square feet. Okay. Well, then do you need to see it worked out? Vincent, this is not stand-up comedy time. If you need to see one worked out, tell me. Otherwise, we don't need a commentary. All right. Number 6. The perimeter is 220 meters. The area is 1,656 square meters. Okay. All right. Anybody need to see that one? Are we good? Number 7. The perimeter is 118 inches, and the area is 870 square inches. Okay, now the rest of these don't have, they only have one answer. Okay? So the rest of these, you only have one, so if you got that one, you get credit. But you do have to include units too. All right, number 8 is 61 miles. Not square miles, so if you have squared, you need to mark through it, and I'll give you partial credit. Okay, number 9. The answer is 48 centimeters. Not square centimeters, just centimeters. 48 centimeters. Okay?
So how I got 768?
Now that I don't know. Do you want to see it worked out?
Yeah.
Okay, let's look at number 9 then. All right, so number 9, we had a right triangle. They said this side was 36 centimeters. That leg is. They said this leg is X, and that this side was 60 centimeters. Okay. They also told you that the area was 864 centimeters squared. Okay. So, what is the formula for the area of a triangle? 1/2 base times height. Okay? Now, normally they give you the base and the height, you plug it in and you find the area. But this time, they gave you the area, you got to find which one of these is the base, which one of these is the height. Okay? So, on this triangle, what's the base and what's the height? Now, remember the definitions. The base is any side, but the height can be a side or can just be a straight line, but it goes from the base and it makes a right angle to the other vertex. So that works here. If we let this be the base, the other vertex is right here, and there's the line that goes to the other vertex and makes a right angle. So the base is X, and the height is 36 centimeters. And the base would be X centimeters. Okay? So let's plug in everything we know. We know that the area is 864, 1/2. The base is X, but the height is 36. Okay? Now, we can swap these around because multiplication is commutative, right? So the reason I'd swap it around is I can multiply these two, but I can't the X. So we need to write this as 864 is 1/2 of 36 times X. Now, what is half of 36? 18, and 18 times X is 18X. So then it's just solving an equation. What is done to X? Times 18. So how do we figure out what X is? How do we undo the times 18? Divide both sides by 18. 18X divided by 18 is just 1X, but you only write X. And 864 divided by 18 is 48, and it was centimeters. And there's your answer. Yes. Next time, copy it down there. All right. Number 10. Okay. The answer is 45 feet. Does anybody need to see number 10? Going once.
What's number? Oh, that's good. 19. Oh, yeah.
I did. Okay. I'm going to put a mark through it if you did not write 45 and feet. If you put a squared, put a line through it because that's wrong. But it needs to be just like this. Okay. Number 11 is 21 meters.
I got it wrong. Can I see it?
Okay. Let's look at number 11. Now y'all can write this, if as I'm working it out, you can write this on your homework because you have a pen. So you can copy it down. In fact, that's what I want you to do. I want you to correct it. Okay, so you were given a rectangle. The width is 13 meters. The length we don't know. And they told you that the perimeter is 68 meters. Okay, well, what is the formula for perimeter of a rectangle? No. 2 times the length plus 2 times the width. Y'all, you only had 3 formulas on this section. You've got that, and then you got the 2 area formulas. Okay? They are area of a triangle is 1/2 base times height, and area of a rectangle is, thank you. Area of a rectangle is length times width. So those were your only three formulas you got to know. Okay? So the perimeter, normally they give you length and width and you plug it in and you find perimeter, but this time they gave you perimeter. So you just plug in what you know. The perimeter is 68. 2 times what is the length? We don't know. It's x. So it's 2 times the length is 2 times x plus 2 times what's the width? I'm not going to do these if y'all aren't paying attention. What is the width of this rectangle? 13. I'm not going to waste my time if you're not paying attention. Okay? Now we can do 2 times 13, and that's plus 26. So then we're solving this equation. Now I like to write it over here, so I would write 2x plus 6 equals 68. You don't have to do that. But you ask yourself what's done to x. And it is multiplied by 2 and then added 6. So how do we undo that? Got to subtract 6 first, because adding 6 was the last thing you did. So you got to do 2x plus 6 minus 6 equals 68 minus 6. What is 2x plus 6 minus 6? 2x. What is 68 minus 6? 62. So now the only thing done to x is multiplied by 2. So how do we undo multiplying by 2? Divide both sides by 2. 2x divided by 2 is simply 1x, which we write as x. 62 divided by 2 is 31, and x was a length, so it's 31 meters. Okay. Wait. They say 21. Oh, that's 26. So it's minus 26, minus 26. So that's 42. Sorry, y'all. I wrote 26, but when I went over here, I just wrote 6. So everywhere there was a 6, that was supposed to be 26. So then that would be 42 divided by 2, which is 21. Sorry. Okay? All right. Last 2. Number 12 is, the width is 35 inches. And let me tell you 13. So if you have 30, if you don't have 35 or don't have inches, put a slash through it. 13 is 32 yards. Okay? Do y'all need to see 12 or 13? Anyone? All right. Well, that's all for 5-1. If you would, Marcus, will you take up the pens that are mine? And Alex, will you take up everybody's homework? And y'all get out a couple sheets of paper. We're going to learn section 5-2.
Do we need some more? Do we switch these?
No.
To the right?
I divided that wrong. It's 32. But yes. So don't mark it wrong. That was me. Okay, y'all hurry up. We got people watching this video waiting on you. Get out paper and pencil for notes. Thank you guys. Do I have everybody's pen that borrowed one? All right. Section 5-2 is how do you solve equations when variables are on both sides? So here we go. 5-2. Solving equations with variables on both sides. Okay. You may remember, but when I first started talking to you about equations, I used a few models to kind of help you understand what it's like. One of them was putting your sock and your shoe on and then having to undo that in the reverse order. There was another one I told you about, and that is the balanced scale, like old-timey scales where you didn't like put something on it and it digitally told you what it was. What you would have to do, and they still use these in a lot of labs, is that you'll have this scale that has like 2 plates on it. And typically you put whatever on here that you want to know the weight, and then you would put known weights of things over here until it balances, right? So the kind I showed you before was like, what if you had an unknown value, so like a rock that you don't know how much it weighs, and then you had 3 blocks that each weighed a pound on this side. Okay? And actually, I'm going to even make it tougher. I'm going to put 2 rocks over here. They're the same. They're the exact same, but we don't know how much they weigh. And then 3 blocks that each are 1 pound. And then I told you that that balanced with 7 pounds. How could you figure out what the rock weighed? There's 2 identical rocks and 3 pounds, and that balances with 7 pounds. So what could we do first? We have to keep the balances balanced, right? So if we put something on one side, we got to put it on the other side. If we take something off of one side, we have to take it off the other side. So what's one thing you see that you could do to keep it balanced? What's something we could take off of both sides? Now, we couldn't take a rock off because we don't know how much it weighs, so we wouldn't know how many of these to take off, right? But we could take these 3 pounds off and take 3 pounds off over here, right? Because if you took the same thing off both sides, you would have, it would still balance. And so what would be left is 2 rocks and 4 pounds. Okay? Now, this last step is a little tricky, but I told you that the rocks weighed the same thing, right? So, I can't actually just say take off 1 rock and take off something over here because we don't know how much this is, right? But if this weighs this, so everybody look up here. If this weighs the same as this, then half of this would weigh the same as half of this, right? So what would half of 2 rocks be? What's half of 2 rocks? 1 rock. Okay. What is half of 4 pounds? 2 pounds. And so you would know then that the rock weighed 2 pounds. Okay. So let me show you what mathematically that was. Here at the top, you had 2 things that were unknown with 3 pounds added to it. That would be 2x plus 3. 2 unknown things plus 3. That balanced with or was equal to 7. So what did we do from here to here? We subtracted 3 from both sides, right? And we got 2x plus 3 minus 3 equals 7 minus 3. Well, 2x plus 3 minus 3 is 2x, and 7 minus 3 is 4. Then the last thing was we took half of both sides. 2 ways you can take half. You can either multiply by half or you can divide by 2. So we divided both sides by 2, and we got x equals 2. Okay? So that's nothing I just showed you is new. Okay? That's what we've been doing all along. But now I'm going to show you what happens if, same scenario, but say you've got five rocks that we don't know how much they weigh and 4 pounds. And that balances with 3 rocks and 10 pounds. Okay. So if you had to write an equation of what this looks like, what would it be? On this side, we have 5 things that we don't know plus 4 pounds, right? So that would be 5x plus 4, right? 5 things that we don't know plus 4 pounds. What would this side be? 3x plus 10. 3 things that we don't know plus 10 pounds. Okay? Before, I've thrown the sheet in the trash now, but before, when we had just rocks on one side, why couldn't you just take a rock off? You didn't know how much it weighed, so you wouldn't know how much to take off the other side, right? But could we take a rock off of this one?
Yes.
Why? There's a rock on both sides. So even though we don't know what it is, we could take it off both sides because there's rocks on both sides, right? And they all weigh the same. So we don't know what that weight is, but if we take one off the right and one off the left, it's still going to be balanced. Before, we couldn't take one off because we didn't know how much it weighed and there wasn't one on the other side, so we wouldn't have known how many pounds to pull off. But now, what you could do, so we know that 5x plus 4 equals 3x plus 10. So what could you do to this to have as few rocks as possible? I'm just saying in the scale. So not even talking about variable. We're not in pre-algebra now. We're in a science class. What could you do to this and it stay balanced that you could get rid of the most rocks?
What could you do with that?
What could you do to this scale and make it stay balanced that would get rid of the most rocks?
Take out two rocks on both sides.
If you did that, yes, you were almost there. You could take 3 off of both sides, right? Because both sides have 3 rocks on them. So if you did that, what would it look like? This side would have 2 rocks and 4 pounds. What would this side have? 10 pounds. Okay, now it's like what we had before. What would we do now to try to figure out how much these rocks weigh? Take 4 pounds off of both sides. If you did that, what would be over here? 2 rocks. What would be over here? 6 pounds. And then last would be the same thing that was before. We can't take 1 rock off and some pounds because we don't know how much it weighs, but we could take half of this side off and half of this side off. What would half of this side be? 1 rock. What's half of this side? 3 pounds. Okay? So every rock was 3 pounds. Let's see if that makes sense. This is 3, 3, 3, 3, 3. How many pounds is over here? That's 15, 16, 17, 18, 19. This will be 19 pounds. What about over here? If this is 3, 3, 3, that's 9 plus 10 would be 19 pounds. So it would balance. Okay? So let's talk about what that happened mathematically. Okay? So if this at the top represents 5 unknowns plus 4 equals 3 unknowns plus 10, what did we do from here to here? We took off 3 rocks. Well, what were our rocks representing? Our unknown value, which is x. So how could we take off 3x from both sides of here? What would that look like? That would be subtracting 5x plus 4 minus 3x equals 3x plus 10 minus 3x. Okay. What is 5x minus 3x? 2x. You still got that plus 4 equals, what's 3x minus 3x? No. 3x minus, what's 3 minus 3? 0. What's anything minus anything? 0. What's 3x minus 3x? 0. 3x minus 3x is 0 plus 10 would be 10. And see, that's what you have. 2 unknowns plus 4 pounds equals 10 pounds. Then what did we do from here to here? No. What did we do? Don't say math words. What did we do from this scale to this scale? Took off 4 pounds. What is that in math words? Subtracting 4. So we've got 2x plus 4 minus 4 equals 10 minus 4. What is 2x plus 4 minus 4? It's 2x equals 10 minus 4 is 6. And see, that's what we had here. 2 unknowns equals 6 pounds. Then we divided both sides by 2, and we got x equals 3 pounds. Okay? So if you ever have a problem that has variables on both sides, all you have to do is add or subtract the variables, the smaller one, from both sides, and then you only have it on one side, and then it's like the ones you've been doing already. Okay? So let me show you what that looks like in pure just equations, where we're not talking about scales or anything. It starts on page 231 in section 5.2. Okay? All right, so let's start solving some of these. Okay. Now, some of you messed this up on the test. There's two very different things. You have to be careful with the directions. When you have an expression that has x's and y's or variables, several of you asked me if you needed to solve it. You can't solve expressions. So pause 1 second. So if you had this, 3m plus 4n minus 7m minus 4n, and the direction said simplify, you are not going to come down and get m equals 2, okay, or anything like that. Simplify just tells me, can we combine any of these? You're never going to find out what the variables equal, because in just an expression, they can still equal anything you want. Now, it's different when you have an equation. When you have an equation, x can still be anything you want, but you're trying to find, are there any x's that make this true? So here you're trying to find out, what does x equal if it says solve. If it just says simplify, you're just going to combine like terms. Use distributive property, any of those things. So like, what is 3m minus 7n? It's 3m minus 7m. Negative 4m. What is 4n minus 4n? 0. So negative 4n plus 0 goes away. The answer would be that. Not m equals negative 4, not m equals 4. M can be anything we want. The only time you solve is when it's an equation, or we're later going to learn about inequalities. Okay? But if you don't have an equal sign, or inequalities, which we learn later are less than and greater than, if you don't have one of those, can't see, y'all got to tell me. If you don't have one of those, you can't solve it. You're just simplifying. Okay, those are two very different things. So now back to here. I just remembered that. A lot of y'all did that on the test. Okay, so how is this different than the ones we've done already? You've got variables on both sides. Okay, so what I said is, if you have variables on both sides, get rid of the smaller one. What's smaller, 3x or 1x? 1x. Now, is that plus 1x or minus 1x here? Plus 1x. So how do we get rid of it? Subtract x. So what we're going to do is subtract x from both sides. So we're going to have 3x minus x equals x plus 8 minus x. What is 3x minus x? What is the coefficient of this x? 1, or negative 1 technically, but yes. So what is 3x minus 1x? 2x. What is 1x plus 8 minus 1x? Just 8. Because 1x minus 1x is 0, and 0 plus 8 is 8. Now it's a very simple equation. How do we solve it? Divide both sides by 2, and we get x equals 4. Now to check it, you write the original, and we want to know, is that true when x is 4? So is 3 times 4, does that equal 4 plus 8? Okay, 3 times 4 is 12, equals 4 plus 8 is 12, so it works. But the answer is x equals 4. The answer is not 12. But when x equals 4, 3x is equal to x plus 8. Okay? All right, I'm going to let y'all try 2. Okay? No, I'm going to write them here. So, just on your paper. I want you to solve 9x equals 2x plus 28. And I want you to do, start working on that one, and I'll write the second one up here. So y'all try to work those two. If you do it to both sides, you can't just subtract it from one side.
So I did do what I did and put -2.
You're going to do 9x minus 2x, and then you're going to subtract it from both sides. So 9x minus 2x, 2x plus 28 minus 2x. What is that? Adding 3x or minus, or plus 3x? So how do you undo minus 3x? Right. Okay, let's work them out. So I'll go slow. Number 1, what do we need to do first? The only thing that's different, before, remember I asked you what's done to x and in what order. Okay? The only thing that's done here is first you have to get x's only on one side. And then it's just like before. Okay? So what could we do to get rid of one of those x's?
X minus 4. I mean, X 2 minus 8.
Subtract what? 2x from both sides to get rid of that one. So you've got, if 9x is 2x plus 28, then 9x minus 2x equals 2x plus 28 minus 2x. Okay? Then, what is 9x minus 2x? 7x, not just 7, equals, what's 2x plus 28 minus 2x? It's 28, because 2x minus 2x is 0, and 0 plus 28 is 28. Now, how do we solve for x? Divide both sides by 7. 7x divided by 7 is 1x, but we just write x. 28 divided by 7 is 4. Okay? You could check it by plugging in 4 into both sides, and you'd see it's true. I'm worried about time, so I'm not going to do it right now. Okay, here. What do we need to do first? Get rid of one of those, right? Is that subtracting 3x or adding 3x? Right there. That's a minus. How do we undo subtracting 3x? We add 3x to both sides. So we got 5x minus 4 plus 3x equals negative 3x minus 28 plus 3x. What's 5x plus 3x? What is 5x plus 3x? 8x. Minus 4 equals negative 3x plus 3x is 0 minus 28. Then what? We're going to add 4 to both sides and get 8x equals negative 24. Divide both sides by 8, and x is negative 3, which you could check. All right, I'm passing out the homework. Hold on, please.